Okay, our last separation technique is going to be column chromatography. Column chromatography is a lot like paper chromatography. If you look at the picture there, you can see pieces moving down. But one big difference is that you're not on paper. That's why one's called paper, one's called column. This column one involves putting some silica gel into a long tube, and then you let it pass through that silica gel. So the difference is the stationary phase with paper chromatography is paper, and with column chromatography is a silica gel. What I'm going to do is actually show you the quick video clip of the process first, because I think it'll help you get a better visual, and then we'll come back and chat about it. There is a part in the video, I'll pause it when it gets to it, because they're going to do column chromatography, and then they'll turn to another type of chromatography. So once it gets there, I'll stop it and we can discuss.
Hi, I'm Rachel. This time I'll be showing you how to use column chromatography to separate a mixture of compounds. Start by packing the column tip with a small amount of cotton to support the stationary phase. Then connect the tip to the column. A funnel is connected to facilitate even addition of sand and silica layers. First, a thin layer of sand is added, followed by approximately 2 inches of dry silica. We now need to prepare the sample for dry loading. This is achieved by mixing the compound with silica and a couple drops of solvent. Continue mixing until the solvent evaporates. The solvent dissolves the compound so that it absorbs onto the silica. Add the mixture on top of the silica layer, followed by another layer of sand. The sand layer helps maintain a level surface when adding the element. Carefully add solvent to the column to begin the elution. Remove the funnel and apply air pressure to the top of the column, speeding the flow of elument. The end of the rubber tube is folded back to create a better seal to the column. When the first compound is about to come off the column, you can begin collecting your fractions. After the first compound is collected, increase the polarity of the element to elute your next compound. Once all the fractions have been collected, you can use PLC to analyze the separation. With a capillary tube, spot each.
Okay, so this is what I was talking about. This part is like paper chromatography because column chromatography won't give you RF values. It will separate the parts of your mixture out in much larger quantities than paper chromatography will, but it doesn't give you RF values. So you would then have to carry out either paper chromatography, or they're using a method called TLC chromatography, which we don't need to understand that one. It's just like paper chromatography, except you do it on a special plate. But you'll carry out some sort of chromatography, so additional chromatography, so that you could find the RF values. So again, big difference is the stationary phase is a silica gel instead of a piece of paper. Now you notice on my paper these colored bands. One of the things I've told you to do right here is before you start to actually color these. So if you have colors on you right now, that's fine. If you're in class watching this, wait, and then you can color these afterwards. But I think the colors really help you see it. And if you take a look at this, you can see that at the beginning, right at the beginning when we put the mixture in, they used green for that. Then immediately when the solvent goes in, and we usually start with a less polar solvent as our first solvent, you can see this start to pass through. So what's happening is the C part must be more nonpolar because it's being dissolved more, because you see it coming through more, and you can see that the C comes through the most. So it must be the least polar because we have a less polar solvent. Remember, like dissolves like. So it's going to pull that C through. Now you see the B is being pulled through as well, but just not quite as well. So once we get all the C out, and you can see right here, we would pass all the C into the container, and then we would have that there. As soon as it all passed through, then you would change the container to just a clear one, an empty one, so that you could catch the rest of the solvent that was coming through. At this point, you might need to add a new solvent. You might need to put in some other type of solvent that's more polar to help pull the rest of this more polar substance through, and then that would pull that one through, and then eventually you'd see here that your second band of color would come through. And so this beaker and this beaker would contain your two parts of your mixture. And then you could take those, you could spot them, and you could figure out their RF values using paper chromatography. So this one, we can use multiple solvents. We usually start with the least polar solvent so that that'll pull the non-polar stuff through, and then we increase the polarity. Okay, and that's pretty much the basics of it. The directions are all there. The video that we just watched is linked down here at the bottom, so if you want to watch it again, you can. But that is the main idea. Again, if you'll change this right here to an A, because that should say chromatography. Oh, look, I did it again. Chromatography. Yep. Okay, silly. Oh my gosh, what the heck word is that? Substance. Wow, catching all sorts of spelling mistakes. All right, I will talk with you later.